General equilibrium theory deals with the problem of whether the independent action of each decision making unit, the consumer or the firm, leads to a position in which equilibrium is reached by all. A general equilibrium exists if each market is cleared at a positive price, with all decision making units being in simultaneous equilibrium. Leon Walrasian, in his book Elements of Pure Economics, introduced the idea of simultaneous determination of prices of all the markets through the interaction with one another, with the help of simultaneous equations of demand and supply of all the markets in the economy. He described a unique solution for all the variables and also described the stability conditions of the equilibrium through the process of adjustments taking place. The basic of the stability of the equilibrium in Walrasian system asserts that the excess demand is inversely related to price. That is, the increase in the excess demand occurs due to decrease in prices.
After studying this module, you shall be able to know about the Walrasian excess demand approach and intent extent approach to general equilibrium. Learn that a general equilibrium exists if each market is cleared at a positive price, with all decision making units being in simultaneous equilibrium. Identify that Walrasian system asserts that the excess demand is inversely related to price. Understand that input output analysis is an analysis of inter-industry relations of the network of intermediate products passing from one industry to another or sold as final products to the consumers. Identify the assumptions to the consumers and limitations of input output. Walrasian system asserts that the excess demand is inversely related to price. The excess demand price is defined as the difference between the price that buyers are willing to pay and the price that sellers are charging for a given quantity. Mathematically, the excess demand at price P can be defined as EP is equal to DP minus SP, where DP is demand price and SP is supply price. It is positive or EP is greater than 0 if DP is greater than SP. It is negative or EP is less than 0 if DP is less than SP.
The general equilibrium analysis describes the mechanism of determination of prices simultaneously in each market, so that there is neither excess demand nor excess supply, while all the economic agents individually attain their respective competitive goals. All the markets in the economy are interdependent on each other. Clearly, any disturbance in one market not only changes the equilibrium position of the concerned market, but also creates impact on the equilibrium positions of other markets in the economy. In what follows, we will examine the impact of changes in demand in one market on all other markets in the economy. For the sake of simplicity, we assume that there are only two sectors of the economy, say 1 and 2.
For the sake of simplicity, we assume that there are only two sectors in the economy, say 1 and 2. Suppose that because of some favorable condition, the demand for commodity A has increased at the same price, that is, the market demand curve of the commodity A has shifted out to the right because of change in preference pattern of the consumer as shown in diagram panel A. In the diagram, the initial level of equilibrium in sector 1 is at point E1. The initial demand and supply curves of commodity A are represented by dA and SA respectively. Equilibrium point E1 gives us equilibrium price PA and equilibrium quantity QA. The equilibrium of each firm in industry A is illustrated in figure B. At equilibrium, the firm produces QA at which AC is equal to MC equals to price equals to MR. Panel B should refer to the equilibrium of a firm in the industry A.
Similarly, the initial equilibrium position of commodity market B are illustrated in figure panel C and panel D. The commodity market B is in equilibrium at price PB, at which demand for B equals its supply. Likewise, each firm in sector 2 will produce QB at which AC is equal to MC is equal to price is equal to MR. Now suppose that there is an outward shift in demand curve of sector A due to change in any factor which influences demand, either change in consumer income, change in consumer preferences, or increase in the price of its substitute goods, etc. Except price of A. The new demand curve is D-A. This cuts the initial supply curve SA at point E2, which gives new equilibrium price P-A and new equilibrium quantity Q-A. In this situation, if consumers are purchasing more of commodity A at higher price P-A with their same income level, they must have to reduce their expenditure in other sectors, that is, in sector 2. So they will purchase less of commodity B, which is reflected by the inward shifting of the demand curve of commodity B from DB to D-B. All this happens because of the interdependence of all the sectors of the economy. In this changed situation, competitive firms in sector 1 will produce more of commodity A at higher prices P-A. The new equilibrium E2 is not at the minimum point of ACA. It is higher vertically than ACA, which implies positive profit TR is greater than TC in sector 1. The total profit is given by the area NC BP-A in the diagram panel B. On the other hand, in sector 2, the new equilibrium price P-B is lower than the average cost or at the output level Q-B. As such, the position is that the firms in industry A are making supernormal profits while firms in industry B are incurring losses. Some firms in industry B are therefore forced to quit the industry and some are induced to transfer their resources to industry A. The process of adjustment will continue till such time a new general equilibrium is achieved in the economy. The new general equilibrium for sector 1 is E3 and that of sector 2 is E-3. Comparing the new state of equilibrium E3 and E-3 with the initial state of equilibrium E1 and E-1, it is clear that there will be change in the resource allocation in the economy. In the new general equilibrium, more resources will be allocated for the production of commodity A compared to the initial one, and obviously less will be allocated for commodity B.
To sum up, due to the change in consumers' preference in favor of commodity A caused by the exogenous factor, demand for commodity A has increased and for commodity B decreased. As a result, price of commodity A increases and that of commodity B decreases temporarily till a new general equilibrium is achieved, in which there is more quantity traded of commodity A at its original price and less quantity traded of commodity B at its original price.
Now we'll move on to the concept of input-output approach to journal equilibrium. The input-output analysis has been pioneered by Wesley W. Leontief. It is an application of journal equilibrium theory. It is concerned with an empirical study of interdependence among various parts or sectors of the economy. It helps in determining the optimum level of production for each industrial unit given the resources and technology, such that the demand for its product is fully met. That is, there are no shortages or surpluses in the economy. The analysis divides the economy into a number of sectors or industries, including households and the government as industries of final demand. Each industry is viewed as selling its output to other industries. These outputs become inputs for the purchasing industry. Likewise, each industry is viewed as a purchaser of the outputs of other industries. Thus, the interdependence of each industry on the other is established. The input-output analysis is thus an analysis of inter-industry relations of the network of intermediate products passing from one industry to another or sold as final products to the consumers.
Therefore, the input output approach to general equilibrium is concerned with an empirical study of interdependence among various parts or sectors of the economy. It helps in determining the optimum level of production for each industrial unit given the resources and technology, such that the demand for its product is fully met. That is, there are no shortages or surpluses in the economy. Assumptions of input output analysis. Input output analysis is based on following assumptions. 1. The economy can be divided into a finite number of sectors, industries. Each industry produces only one homogeneous commodity. No industry produces joint products. 2. Each industry uses inputs in rigidly fixed proportion. In other words, the input requirement per unit of output in each industry or sector remain fixed and constant. 3. Factor and commodity prices are given. 4. The production function of the producing sectors is linearly homogeneous, that is, the production in every industry is subject to constant returns to scale. Uses of input output analysis. Input output analysis has a wide range of applications. 1. Input output analysis is used to obtain projections of demand, output, employment, and investment for a country or region. 2. Input output analysis is helpful in providing necessary information for formulation of economic policies. It is used in economic development planning, studies of interregional and international economic relationships. 3. Input output analysis is useful for national income accounting as it provides detailed breakdown of the macro aggregates and the money flows. 4. The interrelations between various sectors as revealed in the input output table provide indication regarding prospective trends in which they are likely to combine with each other. 5. Given a certain final output target, it can show the production requirements of various sectors. Limitations of input output analysis. Despite its many useful applications, the input output analysis has many shortcomings which are given below. 1. The input output analysis is based on a assumption of fixed input coefficients or proportions. Over time, technology and input price change, and these are likely to greatly affect the proportions in which input are combined in the production of many commodities. This necessitates frequent and continuous updating of input output tables, which are very costly and time consuming. Second, input output analysis is based on linear equations relating output of one industry to input of others. This appears unrealistic. 3. In the input output analysis, labor is the only input which is considered scarce. This is not true in practice. 4. Final demand, that is, the purchases by consumers and the government, in the input output analysis is taken as given and treated as independent of the production sector. Though input output analysis has its shortcomings, yet it is considered an important tool for the analysis of economic decisions of the government and in development planning. Model of input output analysis. Input output is a method of analysis in which the economy is represented by a set of linear production functions describing the interrelationship among all sectors or industries. Because it deals with interdependence between industries, in that sense, input output model is a general equilibrium theory. This model involves following steps. 1. Construction of input output table, also known as transaction matrix. 2. Computing technical coefficients. 3. Formulating a set of simultaneous equations. 4. Solving the simultaneous equations to obtain the values of the unknowns in general equilibrium problem. Construction of input output table, we have assumed that our simplified economy has only two industries, 1 and 2. In the output input transaction, table row 1 shows that industry 1 has produced 1000 units of output, of which 300 units are used up by itself. Industry 1. 600 units are used up by Industry 2. In this way, 900 units have been used up as intermediate inputs by the two industries. only 100 units are available for final consumption. The second row shows that Industry 2 has produced 2000 units of output, of which 400 units are used by Industry 1, 1200 units by Industry 2 itself, and only 400 units are available for final consumption. Again, out of 2000 units produced by Industry 2, 1600 units are used up as intermediate inputs. The last row shows that the amount of primary input labor used by the two industries. In the above table, the first column shows the inputs required by Industry 1 to produce 1000 units of output requires 300 units of its own output, 400 units of output of Industry 2, 20 units of primary input. The second column of the table shows the inputs required by Industry 2 to produce 2000 units of output requires 600 units of Industry 1's output, 1200 units of its own output, 10 units of primary output. The column of final demand shows that for final consumption, the economy needs 100 units of industries I's output and 400 units of industry two's output. The last column shows the total output produced by the two industries and the total requirement of primary input labor. Generalizing to n industries, we write input output table where x1, x2, so on xn is total output of different sectors or industries in an economy. F1, F2, so on Fn is amount of final demand. X11, X12, so on X1n is amount of output of sector or industry 1 used as input in sectors or industries 1, 2, 3, so on n. X21, X22, so on X2n is amount of output of sector industry 2 used as inputs in sectors or industries 1, 2, so on to n, and so on. From table, we get x1 equal to x11 plus x12 plus x13 plus and so on to x1n plus f1. So in general, we sum up the outputs we get. Xi is equal to summation of xij, where j goes from 1 to n plus fi, where I equals to 1, 2, so on to n. Xi equals to total amount of the ith sector or industry. XIF equals to output of the ith sector or industry used as input in the jth sector. Fi equals to final demand for the ith sector or industry product. Technology matrix, which would indicate the amount of the output of the ith sector industry, which is used as input to produce 1 unit of output of the jth sector industry, we call it Aij. Ij equal to 1, so on to n. Given constant return to scale, Aij will be constant and fixed for all i's and j's. Now, Aij equals to xij by xj, or xij equals to aij into xj. The above given input output transaction table can be put in terms of technological coefficient matrix. This matrix is known as technological coefficient matrix. We know xij equals to aij into xj, where xij is the output of industry or sector I required to produce the output of industry or sector J, and is proportionate to the output of industry J. The coefficient of proportionality being the input output coefficient Aij. Its value is usually positive but less than unity. If sector or industry J does not buy any inputs from industry or sector I, its value will be 0. In symbols, 0 less than equal to Aij less than equal to 1. If there are n industries sectors, the following is true for each of them. Xi is equal to summation of xij, where j goes from 1 to n plus fi. I j equals to 1, 2, 3, so on to n. Or xi is equal to summation of aij xj, where j goes from 1 to n plus fi for all I. Equation is the balance equation which states that the output for any commodity I is used either as the input for the production of commodities J or as the final demand. This is an equilibrium condition which states that the quantity of output supplied is equal to the quantity of output demanded. Solving the simultaneous equations to obtain solution. This equation can be put in a matrix form. This matrix can be represented in the form of an equation: x equals to ax plus f, x is equal to total output vector, a is equal to input output coefficient matrix, f is equal to final demand vector. Now we have x equal to ax plus f, x minus ax equals to f, I minus a into x equals to f, x equal to I minus a to the power minus 1 into f, where I is identity matrix, a is technology matrix, and IA is called Leontief matrix. By solving the given equation, we can determine the output levels for various industries, sectors of an economy.
Let us now summarize what we have learned in this module. The fundamental feature of any economic system is the interdependence of its constituent parts. The partial equilibrium theory is an inadequate tool for analyzing this interdependence between the basic microeconomic units, namely the consumers and firms. General equilibrium theory, on the other hand, is basically designed to deal with the problem of interdependence. It seeks to analyze the interaction of the consumer and the firms in the determination of prices and quantities of goods and factor inputs. Any disturbance in one market not only changes the equilibrium condition of the concerned market but also creates impacts on the equilibrium conditions of other markets in the economy. All the markets in the economy are interdependent of each other. General equilibrium exists in an economy when all the markets in the economy are in equilibrium simultaneously. Walrasian system asserts that the excess demand is inversely related to price. That is, the increase in the excess demand occurs due to decrease in prices. The input-output analysis has been pioneered by Leontief. It is an application of general equilibrium theory. It is concerned with an empirical study of interdependence among various parts or sectors of the economy. The input-output analysis divides the economy into a number of sectors or industries, including households and the government as industries of final demand. Each industry is viewed as selling its output to other industries. These outputs become inputs for the purchasing industries, which is viewed as a purchaser of the output of other industries. Thus, the interdependence of each industry on the other is established.